My topic is flat trusses. History of truss. Early truss was made out of wood and first used by the ancient Greeks and the Romans. Trusses have been used for many centuries. During Renaissance, Andrew Palladio illustrated truss bridges in his 4 books of architecture as early as 1570. The influence of the 19th century iron transport in Henry Bible Technician Reading Room in Paris can be seen in the vaulted ceiling above the main concourse in Mint and White Pennsylvania Station in New York City. While tradition of long-span behind arch trusses optimized in such 19th century masterpieces as Contamine and Daughters Gallery that's mentioned in Paris, continues in 20th century structures like Peter's Barrien's AEG turbine factory in Berlin and Tony Garnier's municipal slaughterhouse in Lyons, France. Trusses were used deliberately as expressive elements. Within later 20th century architecture, it's more often by appropriating and reinterpreting the industrial applications. Architects and engineers are always seeking new ways of solving the problem of space enclosure. With the industrialization and development of the modern world, there is demand for efficient and adaptable long-span trusses. Because of their light weight and high strength, they are among the most commonly used to span long length. Trusses provide complete flexibility in exterior cladding. And materials could be wood truss span, still commonly used, and the precast truss span. Truss can be 2D planar or 3D prismatic. What distinguishes the truss from other structural forms is precast triangulation. The definition, a structure is a relatively permanent enclosed construction over a plot of land having a roof and usually windows, and often more than one level, used for any of a wide variety of activities as living or manufacturing. A structure can also be defined as anything built or constructed. The structural system is that which transfers loads through interconnected structural components or members. The role of any structural system is to transmit the applied loads to the foundation. Two main kinds of structure, the multi-story structures and the large span structures with a span larger than 20 meters. For the classification of the structure systems, we can divide them into 3 parts: vector active structures, surface active structures, and the form active structures. For the vector active structures, we can divide them into 3 parts: flat truss, curved truss, and the space truss. As I said, my topic is the flat trusses. So what is the vector active truss? Vector active structures are systems of short, solid, straight linear members in which the redirection of forces is affected by multidirectional splitting of single force simply to tension or compression elements. And by the way, when you click on some photos, you can access websites from here, as you can see. For the flat trusses, what is flat trusses? In architecture, a truss is structure comprising one or more triangle units constructed with straight members whose ends are connected at the joints referred to as nodes. External forces and reactions to those forces are considered to act only at the nodes and to result in forces in the members which are either tensile or compressive forces. Moments are explicitly excluded because and only because all the joints in a truss are treated as revolutes. A planar truss is one where all the members and the nodes lie within a two-dimensional plane, while a space truss has members and nodes extending into three dimensions. The top beams in a truss are called top chords and are generally in a compression. The bottom beams are called bottom chords and are generally in tension. The interior beams are called webs, and the areas inside the webs are called the panels. As you can see here, flat trusses and the transmitted flat trusses. For the flat truss systems, we can divide them into, as you can see, 4 parts: top chord systems, bottom chord systems, two chord systems, and the camber systems. Symmetrical piece lattice steel roof on columns. Symmetrical piece lattice steel cantilever roofs on steel columns. And the final, lattice girder flat roof with secondary steel beam on steel the columns. For the transmitted flat truss systems, we can divide them into 3 parts: and the linear system, folded system, and intersecting systems. Flat trusses, all members and nodes lie within a two-dimensional plane, consist of straight members connected at joints. No member is continuous through a joint. Each truss carries those loads which act in its plane and may be treated as to the structure. When forces tend to pull a member apart, it is in tension. When the forces tend to compress the member, it is in compression. Members of a truss are slender and not capable of supporting large lateral loads. The main uses are the first one, in building to support roofs and floors to span large distances and carry relatively light loads. In building to support roofs and floors to span large distances and carry relatively light loads. And the second one, in road and rail bridges for short and intermediate span, and in footbridges. And the design possibilities through differentiation of roof planes in continuous trusses. Inclined roof planes with both ends supported. Turning horizontal roof planes with both ends supported. And the third one, alternating horizontal roof planes centrally supported. And the last one, roof planes with differing inclination centrally supported. And the wire truss used in Paris Pompidou building. The entire architectural concept relies on exposed truss work. Long span interior floor trusses define column-free exhibition zones and exterior wind. Bracing trusses create the graded diagonal pattern of the facades. The main uses are the last one, as bracing in buildings and bridges to provide stability where the bracing members from a truss with other structural members such as the columns in a building. Example about the bracing buildings: John Hancock Tower. Vertical wind bracing trusses typically hidden within the framework of tall buildings are given similar architectural expression on the exterior. Skidmore, Owings and Merrill's Hancock Buildings, Chicago. And thank you for listening to me. That's all.